Welcome back to the channel. If you want to keep up with the real mechanics behind the tech industry, hit that subscribe button. Right now, millions of people are asking an AI to write an email, translate a document, or fix a line of code. You type a few words, and within seconds, an answer appears on your screen. It feels entirely effortless. We usually measure the price of this access through monthly software subscriptions or the cost of the latest graphics card in our machines. But those are just the retail prices. Every time an answer materializes on your screen, it requires a massive physical supply chain. Generating text relies on harvested data, thousands of invisible workers, and massive amounts of natural resources. To teach a child what a cat looks like, a few pictures will do the trick. To teach an AI, you need thousands of images from different angles, lighting, and styles before the system identifies the concept. These systems are built by ingesting enormous collections of information. Developers scrape vast portions of the public internet, gathering articles, books, and photos, combining them with licensed materials to build a baseline of knowledge. This chart shows the sequence of how AI processes your questions. The ingestion doesn't stop once the system is live. Your prompts and interactions are often retained and fed back into this loop to continually refine the model. A casual question typed on your phone triggers a highly complex computational process happening in real time deep inside remote facilities. The term artificial intelligence suggests a machine thinking on its own. In reality, these systems depend heavily on a massive, distributed human workforce. Thousands of people sit at computers around the world, performing highly repetitive tasks. They draw bounding boxes around pedestrians, classify lines of text, and manually compare generated answers to tell the engineers which one makes more sense. Some workers have a much tougher assignment. To build safety filters that block harmful outputs, data workers have to manually review and categorize highly disturbing and graphic material, a job that carries a well-documented psychological toll. Take away this invisible human labor, and the algorithms would be entirely incapable of safely navigating the real world. All this processing happens on specialized computers housed in sprawling warehouses that run day and night. Running millions of calculations per second generates an intense amount of heat. This chart shows the exponential growth in energy and water required for server cooling. As infrastructure expands, resources needed to prevent meltdowns scale up rapidly. Because new chips outpace old ones, servers are swapped out, adding an expanding pile of electronic waste. This heavy resource footprint exists alongside distinct benefits. Scientists use these same server farms to model climate change mitigation, optimize renewable energy grids, and accelerate medical breakthroughs. The challenge is acknowledging these immense resource demands and deciding how to balance them with the very real solutions the technology offers. Hitting Enter on a keyboard feels like a solitary action, yet that single keystroke instantly activates a global network of engineers, data workers, and industrial-scale machinery. We use the word cloud to describe this network, but the cloud is made of concrete. It is built from sprawling warehouses, tangles of power lines, specialized cooling pipes, and thousands of human beings. There is no independent digital realm. Every piece of convenience we experience on a screen is extracted directly from the physical world. When electricity entered our homes and when the internet connected our computers, society had to adapt to structural changes and environmental costs. Now we have to figure out how to demand better energy efficiency from data centers, push for clear transparency on how our data is used, and ensure safe conditions for the people training these models. So where do we draw the line? How much environmental and human impact are we willing to accept in exchange for faster computational progress? Let us know your perspective. Leave a comment below, hit the like button if you found this helpful, and click one of the videos on screen to keep learning. Understanding the physical weight of our digital tools is the first step toward making sure we use them responsibly. Thanks for watching.